Welcome to this course on Introduction to Redux. This is brought to you by Eric Green and Wintellect Now. So for a quick overview of the course, we're going to take a look at why we use Redux, what problem is being solved, how does it work, what are the underlying principles and ideas behind Redux. We'll take a look at that to better understand why we're using it as a tool. We're also going to take a look at some of the essential JavaScript concepts surrounding Redux. Now, technically, you don't have to use all of these concepts we're going to go over, but they are quite helpful and you'll see them commonly used in Redux applications. Next, we have reducer functions. These are kind of the heart and soul of the Redux application. These are the functions that are actually used to take in the action and then modify the state in response to those actions. So we'll spend quite a bit of time talking about those as well. Next, we're going to talk about actually working with the stores. The stores are what contain the actual state data as well as apply the reducer functions to that state using the actions. Next, we'll talk about combining reducers. In very large applications, it's very common to actually take a reducer and break it out into many functions and then kind of combine it together to do those state manipulations. We're actually not going to be using Redux React. Instead, we're actually just going to take React and kind of manually integrate it into Redux to see how the two of them can work together. We'll also be tying in asynchronous operations and taking a look at how state works with asynchronous ops. Why Redux? Why this library? What does it actually do for us? One of the most challenging things to do in a JavaScript application, especially a large one, is to actually manage the application's state. How do we manage that list of widgets or manage information about the UI itself as the user is interacting with the application? How do we make sure that we communicate the state information across the entire app and that it stays consistent? These are some of the problems that Redux kind of helps us solve. It does this by employing a predictable state container, which basically simplifies our state management. We'll take that term apart, predictable state container, in a few slides. But that's basically what Redux is using to help simplify this process. Now, the best way to think of an application is really an application is nothing more than an initial state followed by a series of actions. So when a program is actually running, it loads up with that initial state, and then as users interact with the program, their actions change the state of that application. And Redux jumps into that process and helps to manage those state changes for us. Each action reduces the state to a new predictable state. That means that if we have a given action and a given state, and we run it through Redux, through our reducer function, it will produce a new state that we can predict. If we take that same action and that same state again and run it again, we'll get the same new predictable state. You'll never have the same action with the same state and it will yield like a different state result. It will always yield the same one. Now, of course, if you take an action and apply it to the state over and over and over, that could come up with different states. But if you have the same state and the same action and you put the two of them together, you always get the same predictable state. And it's this new state that's produced is what's used to actually transition the user interface in the application. So when we get that new state, we then transition from whatever the previous UI look was to basically the new view being displayed. Now, a state container, also known as a store, contains two things. It contains the reduction logic, which is implemented with pure functions. We'll talk more about that shortly. But it also has the last reduced, or what might be called the last current state. So whatever the last state was after the last action that came through, that state is available to us through the Redux store. So what are the three principles of Redux? These three principles are essential to being able to write and create Redux applications. First of all, single source of truth. There is one application state in the Redux application, only one. All aspects of the UI that need to be updated come from this application state, from this one application state managed by Redux. But there's also another concept of a single source of truth. All actions that occur in the system, all of them flow through the Redux store. So not only is there only one application state, but all actions will flow through that as well. The second principle of Redux is that the state is read-only. That means we're going to have to use immutable programming to produce new states. You cannot mutate the existing one. Finally, changes are made with pure functions. Pure functions basically are functions that have no side effects, and their output is always derived from the inputs combined with whatever processing logic is inside the function. So, single source of truth. If you think of a flux pattern, in the flux pattern you have that unidirectional data flow where it goes from action, dispatcher, to store, to a component. And then the component itself then triggers new actions, which kind of flows through the whole process again. It works that way with Redux too. Redux is really kind of like Flux in a way. It's kind of like a dispatcher and a store kind of combined together, and you only have one store. But the idea is that the data all flows in a unidirectional manner. So you have a single source of truth in terms of where the different parts of the system are getting their data. For example, the components will always get their data from the Redux store. The Redux store will always get its changes through the actions. The actions will always be generated either from a component directly or through some other asynchronous mechanism inside of a web browser. Now, no part of this system can ever receive data from two sources. That would kind of break the whole unidirectional data flow and violate that principle. Also, the state, once again, managed by Redux is for the whole application. You don't have multiple Redux stores. You don't have multiple application states. There might be one little minor exception for this for those of you who are familiar with React. I make the little exception that when you're building your input forms and you're setting up your state for that form, just for the purposes of capturing input, I don't pass all of that through Redux. But when it comes to the overall application state, all of it is managed by Redux. The state is read-only, can never be mutated, never ever mutated. The state object must always be updated in an immutable manner. Now that doesn't mean that the object has to be like a deep copy or something like that every time there's a change. It just means that whatever is being changed has to produce something new. You can't mutate something that's already there. Now in order to do this, we're going to have to use immutable programming techniques. Now there's libraries out there like Immutable.js and stuff that will help you do this. We're not going to look at those. We're going to look at the built-in functionality in JavaScript for doing immutable programming. But in order to work with the state, you are going to have to use those techniques. Finally, the changes are made with pure functions. The functions basically use the inputs, which would of course be the state and the action, and it produces a new state from that state and action. Produces no side effects. You won't be making any type of database calls or asynchronous operations or anything like that using the reducer function. It simply just receives inputs, it has an output, and it's a pure function, meaning there are no side effects. And usually what happens for larger applications is you have multiple reducer functions which are combined together to actually produce the actual Redux store for the application. So, the definition of Redux. From the Redux website, it says, Redux is a predictable state container for JavaScript apps. What does predictable mean? Predictable means that the state changes follow the three principles we just discussed. State is the application's data, including the data related to the UI. For example, like what column are you sorting on, in addition to the actual data itself being shown in the column. Container. Redux is the container. All right, it's going to apply the actions that are received to the state through the pure reducer functions. And it's going to return back a new state. All right, Redux does not provide reducer functions, and it does not provide any type of predefined state object. You're responsible for providing both of those. But Redux takes care of the process of actually handling the actions when they come in, calling the reducer functions, returning back a new state, and then notifying those things which have subscribed to the new state, notify them that there is in fact a new state. And finally, Redux has been designed for JavaScript applications. Okay, it's written in JavaScript, it's for JavaScript apps. It's not limited to React or anything like that. You could use it with Angular, you could even use it for Electron applications. So how does Redux differ from Flux? If you don't know what Flux is, you can just kind of skip this slide, but if you're coming from a Flux background, how is it different? Well, first of all, it does share some similar concepts and principles, such as that unidirectional data flow. But where it does differentiate is with the dispatcher and the store. Flux supports a separate dispatcher with many stores, whereas Redux basically says, hey, I only need one store. Well, if I only need one store, I don't need a separate dispatcher. And it actually combines the two of them together. And I call it the dispatcher store. And to create one of those, we'll be using Redux's create store function. Let's talk a little bit about our development environment. We're going to be using Visual Studio Code with Google Chrome. And we're also going to be using the Chrome extension for Visual Studio Code so that we can do some in-editor debugging of our TypeScript code. That's right, we're going to use TypeScript for this. We're going to have a REST server provided by the JSON-server package and a web server provided by Browser Sync. Browser Sync is really nice. This will allow us to get some easy, free, live reload. We're going to be using TypeScript for our application. We're using TypeScript for a couple of different reasons. We would like to have some module support because ES 2015 modules are not currently supported by any of the JavaScript engines. And we want to have some strong typing. Redux has an actual TypeScript type definition file built directly into the distribution of it. So it's really nice. You can get good, strong typing support. We are going to be using ES 2015 for all of our code, but we are not going to be transpiling all of the ES 2015 down to ES5. We are actually going to be transpiling the ES 2015 to just simply ES 2015. The reason we need the transpiler is to actually add the support for the ES 2015 modules and JSX support for the React stuff at the end of the course. TypeScript will be transpiling the ES 2015 module syntax to the universal module definition format. The UMD modules are basically kind of like a compatible hybrid of AMD and CommonJS. In addition to working with those two systems, we can also use a dynamic module loading system called System.js to actually load up our UMD modules into our web page. Typically I like to use Webpack, but I thought for this demonstration we would take a little bit different approach to how we would be working with our modules. And so using System.js to load up UMD modules sounded pretty interesting. Now, the ES 2015 code, as mentioned before, is not going to be transpiled to ES 5.1. It will run natively as ES 2015. This is actually really important because sometimes when we're doing all this ES5, ES 5.1 transpilation, the code that's resulting isn't really pure running ES 2015 code. What do I mean by that? Well, when you use a transpiler, sometimes the code that's produced allows special oddities to occur. For example, if you were to transpile an arrow function to ES5, the arguments object is not actually accurate. The arguments object will reflect the arguments for the actual arrow function. But in ES 2015 code, when you use the arguments object, it actually doesn't include the values for the arrow function. It includes the values for the surrounding function around it. And so those little behaviors can become problematic because people can write code based upon what the transpiler produces. And if they write code based upon what the transpiler produces, if at some point in the future that transpiler gets turned off, or at least turned off for doing the transpiling of the ES 2015 code, you're going to have all kinds of bugs in your program. So if possible, if your user base, if they're all using modern browsers and their browsers all support ES 2015, using a transpiler for things like JSX or to do the strong typing is great, but you might want to consider turning it off for the ES 2015 code. Otherwise, you might be using ES 2015 the wrong way and not even realize it. And then finally, all of our development tooling, kind of like most web projects these days, is totally driven by Node.js. Node.js is going to be powering the web server, the REST services, all of the transpilation, configuration, and everything else. So we'll be using Node.js for that. For our project, we'll actually be using the latest version of Node, so it'll be 6.0 or greater. So let's do a quick demonstration on how to set up our development environment for our Redux React project. To get things started here, we need to pull down our Redux React Starter project. This project is available here on GitHub. Let me open up the console here and I'll paste that in there for you. There you go. If you'd like, you can clone it to your local machine. You can fork it. If you'd like, you can just simply download the zip file. However it is you want to make use of this. This will have all the files that are needed to actually write our Redux React application. So I'm going to close this. I'm going to come over here and actually copy this address, and then I'm going to fire up my console here. So there's my command prompt, and I'm going to change into my folder, and I'm going to clone. Now once you've cloned this to your machine, you'll need to install the packages. To do that, we're going to actually change into Redux React Starter. Make sure you have Node version 6 or later installed, as I have here. Then you're going to say npm I. This is going to install all of the Node packages that our project needs. Okay, now that our project has finished downloading its dependencies, let's go ahead and open up Visual Studio Code and kind of take a look at the overall project structure, and then we'll fire the thing up. So we'll come over here to File, and we're going to say Open Folder, and let's grab our Redux React Starter folder there. There we go. Okay, so here are all of our folders and files for our project. Let me zoom in a little bit, make that a little easier to see. In fact, sometimes people will ask me, why did I switch from Atom over to Visual Studio Code? Well, from a teaching perspective, one of the things that's nice about Visual Studio Code is that the actual folder list actually zooms in out of the box. With Atom, the default tree view doesn't zoom in and out when you zoom the editor in and out. And so that's actually a really nice feature that you get with Visual Studio Code, just kind of ready to go. You can zoom in on the menu, making it easier for people who might be seeing your presentation to be able to see the actual file listings and such. Now over here we have a couple of different things that we're using to build our project. First, we have our package.json file. This is going to have a bunch of metadata, some pre-configured script commands. We'll take a look at some of those. It'll also have our various dependencies. As you can see here, for most node-based projects, the dependency list is actually pretty small. Pretty much just we have React, Redux, and then System.js for loading modules. And we have a few things behind the scenes for doing our web server, browser sync, our JSON server, concurrently, so that we can run both of these concurrently, as well as our TypeScript compiler, and then the typings command for installing the TypeScript type definitions. We have a tsconfig JSON. This just configures our TypeScript compiler. We're using UMD modules. We're targeting ES6. We're going to use the node module resolution. We have source maps. We have decorators turned on. Don't remove the comments. No implicit any is equal to false. That way, if we don't want to do strong typing for something, it doesn't complain. And then we have JSX turned on for our React code. Typings, we have two typings that we've actually installed kind of globally within our system, React and React DOM. Fortunately for us, with Redux, the typings come as part of the package. So if you actually go into the Redux node modules folder, you'll see a TypeScript type definitions file. And let's see here, db.json, this is just seeding our database with some initial data. Inside of typings here, these are where the type definitions all got installed for React and React DOM. Node modules are the node modules for our project. And then underneath JS, we have a bunch of demo files. Now we're going to run this in a second just to verify everything works. And then we're going to delete all of these files and actually start with a fresh folder. Now underneath VS Code, we have this launch.json. This is so we can attach to Chrome with Visual Studio Code. We can actually do, like, breakpoints and watches and stuff like that inside of Visual Studio Code instead of having to do it directly in the Chrome developer tools. Kind of a nice feature. So let's close that. Now what we're going to do is we're going to go ahead and fire this thing up so that we can verify that all the pieces that we need are actually in place and working. So we're going to come over to here and we're going to hit Control backtick. Control backtick will open up the terminal window. This works on Windows as well as Mac. I'm sure it works on Linux too. I haven't tried, but it's a built-in basically command line window that you can run commands from. So we're going to come into here and say npm start. What this is going to do is fire up the web server, the REST server, as well as our TypeScript compiler. So we'll give this a second, should open with Chrome displaying our web page. There we go. And you can see we have our actual list of widgets. This list of widgets is actually being retrieved from the JSON REST server we have set up. So if we come over to here and say localhost 310/widgets, you'll see we get our list of widgets, and that's what we're populating the table from here. So it looks like everything worked for us. The whole project's up and running. Let's take a look at some of the essential concepts in JavaScript that we need to learn about. Now, before we can dive into Redux, we need to make sure we cover some essential JavaScript and web browser API concepts. We need to talk about object.assign, immutable array functions, function parameter default values, arrow functions, destructuring the spread operator and the rest operator, fetch and promises in ES 2015 modules. A lot of new concepts in here to actually build Redux applications. Now, Redux itself doesn't absolutely require all of this, but when you look at Redux applications, you're going to be seeing them use the latest and greatest JavaScript stuff. So we want to make sure that we know how to do that as well. So what is object.assign? It's basically used to copy properties from one object to another. It's really an implementation of the mix-in pattern for JavaScript. You will use object.assign all the time in your reducer function for basically producing new state objects and then copying over the properties from the original object that were not changed at all. Immutable array functions. A lot of folks want to jump to immutable.js or something, but the truth is there's a lot of immutable stuff you can actually do in just plain old JavaScript. So we'll talk a little bit about slice and concat as opposed to using, let's say, push or pop or splice. Function parameter default values. This is really nice for the reducer function to be able to initialize the state parameter if no value is passed in. Arrow functions. We're going to use tons of arrow functions all over the place. We'll kind of briefly go over what those are. Destructuring spreads and rest. These basically make working with properties easier. We'll see some examples of that in the code we're going to work with. Pulling down data. We are going to actually call into a REST API towards the end of the course. We're going to go ahead and use Fetch. Fetch is a newer API, not available in all the web browsers, but it's a newer API. I'm pretty sure it will eventually end up becoming a standard. It also natively uses promises, so we'll take a quick look at promises too and kind of see how that fits into building a Redux application. We will not be using the actual middleware with Redux for doing asynchronous operations. We're going to do it manually ourselves to better understand the management of state. And then the ES 2015 modules, we're going to go through those because we'll be using them throughout our application. So let's do a quick demonstration taking a look at some of these essential JavaScript concepts. So now that we have our project up and running, let's go ahead and do a quick review of some important JavaScript concepts that we'll actually need to know in order to do real Redux programming. So what we're going to do is come over here to our project, and you're going to see we have this JS folder. We're actually just going to kind of delete all of this code. This code here was just kind of to make sure that everything was up and running with our project, but we're going to basically be coding everything from scratch. So come over to your JS folder, and actually before you delete it, make sure you actually kill your web server. Otherwise it'll give you a warning saying it can't delete it because the files are locked. Let's go ahead and delete. Move that to the recycle bin, and we'll go ahead and add a new folder in here. So we'll say JS. Here we go. And then inside of here, we're going to specify app.tsx. So we'll say new file app.tsx. Okay, so there we go. So there's our TSX file. We can put all of our TypeScript code in there. If we're using React, obviously we can use JSX in this file as well. So let's close package.json. Let's go ahead and fire up our web server here. Excellent. So now what we're going to do is go ahead and actually explore some of these JavaScript concepts. I want to go ahead and start off with object.assign first. So let's come back over to here, and what we're going to do is we're going to create a new variable, constant, and then we're just going to put some properties on this thing. So we'll create a variable here called person, and we'll give it a first name. Let's actually zoom in here a little bit. There we go. And we'll actually just collapse that down. We'll say first name Bob, last name Smith. There we go. Now, what I want to do next is I'm going to use something called object.assign. Object.assign will copy properties from one object to another object. So we'll just create another variable here called const new person. And then here we're going to say object.assign. And then we're going to pass into this thing a new object. So this is actually going to produce a new object. And then copy over the properties from the person object. So we'll say person. There we go. And then we'll come into here and say console.dir new person. All right. We can also say console.dir person. So we have the original and the second one. And then I'm going to do one last little thing here and say console.log person triple equals new person. So we want to see the content of person, which is clearly going to have first and last name. We want to see that new person will also now have first and last name. But what we're also going to see is that person and new person are not the same object. So we'll go ahead and save that. Come back over to our web browser here. Open up our developer tools. Take a look. So here's first name, last name, Bob Smith. First name, last name, Bob Smith, and then false. Now this is super important because one of the big reasons we're going to be using object.assign is that later on when we're creating our reducer functions with Redux, we can't actually mutate the state. We have to produce a new state object. And one way of producing new objects while still retaining the properties of the original object is to use object.assign. Now you can actually specify additional properties on here as well. For example, we could say age, and we'll make Bob 23. Now what this is going to do is create a new object, copy the properties of person to that new object, then copy the properties on this object to the new object. And you can actually put as many of these as you want in terms of being extra arguments to object.assign. And that will allow us to produce a new object and basically pull in all of the properties of all the other objects. So this is a very important technique when working with Redux, the ability to use object.assign to mix in properties from other objects onto a new object. Now let's take a look at immutable array functions. Often when we work with applications, we work with arrays of data. Maybe we have a list of widgets or a list of colors or a list of other data items, and we need to work with that list and manipulate it. The key in Redux is working with that list in an immutable manner. So for example, if I had an array here of colors, so we'll say colors, we'll do red, yellow, orange, and blue. Now, typically, if people wanted to add a color to this array, they would say colors.push, and then they'd add a new color, and we could say green. The problem, though, is that this actually mutates the array. And the issue is let's say you actually add an item and then remove an item. How do you know if the array was actually changed? You can't look at the length. And so what ends up happening is you have to kind of iterate over the items and kind of compare them. Well, the problem is that's great if you have 5 items, but what if you have 1,000,000 items? That would take forever. So commonly what people will do is instead of mutating the existing array, they'll produce a new array. So what we can do is we're going to produce a new array here. So we're going to say var new colors, but this time instead of saying push, we're going to say concat. By doing concat, this is actually going to add green to the array, but it doesn't mutate the underlying array. It produces a new array. So we'll say console.dir colors, console.dir new colors. There we go. And now we'll come back over to here and take a look. There's our original array. There's our new array with our green down there. Now, what if we wanted to actually remove something from the array? We can do this with something called slice. Slice will remove stuff from the array and produce, once again, a new array. For example, we could come into here and say slice 1. And now let's look at our new array. Now you'll see we have yellow, orange, and blue, when previously we had red, yellow, orange, and blue. So it removed the first one from the array. But notice the underlying array was not modified anyway, in any way at all. And we can actually do all types of interesting things with this. We can come up with ways of, for example, removing stuff from an array or inserting things into the middle of an array, that kind of thing. So it's kind of nice what you can do with concat and slice. And this doesn't require the addition of any third-party libraries. You just have to choose to use those functions instead of shift and unshift and splice and push and pop. You just use concat and slice, and that will actually do everything that you want in terms of allowing you to produce new arrays by inserting and removing and replacing values in an array. Okay, let's go ahead and talk about some issues related to functions. Like I said before, none of this is absolutely necessary in terms of using arrow functions and default parameters and stuff like that when working with Redux. But it is very helpful if you know how to do that. So let's go ahead and take a look at how to create an arrow function. So I'm going to say const do it, and here's my function. So if we take a look at the code here, you're going to see that we have this open and closed parens right here. This is where any parameters would go that we want to have defined for our function. And then we have what's known as a fat arrow. And then we have this set of curly braces here, which basically is going to be a statement block. Now the statement block is technically optional. If you wanted to, for example, you could actually just have some type of expression here. So we could say we could do that right there, and then when you invoke the function do it, it's simply going to return back that string. This is a test. Now, if we come back to here, though, we can also specify a statement body and just say console.log. And then run some type of command here. There we go. And now come back over to our web browser, and you can see we get the same output. In addition to that, we could have also just simply said return. And then once again, outputted it this way. We'll throw in an extra exclamation point there just to see a different output. There you go. Now, passing in parameters. Like all functions, we can pass in parameters, so we'll have like a parameter A, B, and C. And this time we'll just do console.log A, B, C. And then we can come down here and actually invoke do it. 1, 2, and 3. We'll go ahead and save that. And then pop back over here to our browser, and you can see we output 1, 2, and 3. Now, one of the additional things that we can also do, which is incredibly useful, is that we can specify default parameters. So for example, I can say A equal to 1, B equal to 2, and C equal to 3. We'll actually use this in Redux to initialize our state object if 1 is not supplied when the reducer function is called. So we'll go ahead and save that, come back over to our web browser, and you can see it still outputs 1, 2, and 3. If we were to come in here, for example, and change that to 4, get a different set of values, now we get 4. But we have the ability to specify these default values right here in the parameters. And this is a very, very useful capability for working with Redux. Another couple of cool concepts are destructuring spreads and the rest operator. So let's take a quick look at those. So if I have an object here, person, and I have first name, Bob once again, last name, Smith, I can actually come in here and declare some variables using destructuring that will basically pull in the values of those two properties. So I could say first name, last name equal to person. See how that works? And so now basically what we're doing is declaring two variables, but these variables are going to be picked off of the person object, off of its properties. So now if I save this, and then I come back over to my web browser, you'll see it outputs Bob Smith. Now sometimes I want to rename these. Instead of saying first name, maybe I'd want to say FN, and then maybe instead of last name, I want to say LN. We have the ability to rename those to new variable names in case the property names are not what we're looking for. So let's go ahead and run this code right here. So we'll save that. Then we're going to come back over to our web browser. And you can see we still have the same output over here. And we could come in and put an exclamation point in just to see some different output. There you go, right there. Now, in addition to doing object destructuring, we can also do array destructuring. So we could say const colors, and then we could do red, blue, and green. And then we could come into here and do something like this. We could say const, we could say favorite color, second favorite color, and then assign colors right here. There we go. And then we can say console.log fav color, and you can see now where it's going to pull off that first one off the list. So now if we jump back over to here, you'll see where it outputs red. Now in addition to that, we can use a rest parameter to actually pull in the rest of the colors. So we can say other colors, and let's add another color or two on there. And then we can just change this to be other colors. And this will have all of the extra colors beyond the red and the blue. So this will be fav colors red, second fav colors blue, and then all the rest of them are the other colors. So if we come over to our browser now, you'll see we have an array, green, yellow, and orange. All right, so this is another way of easily working with arrays using destructuring, but then also using the rest parameter. Now, in addition to all of that, we can also apply the rest parameter to function calls or to function parameters here. So let's create a function once again called doit, and we're going to say a comma b, and then we'll do c. Notice the dot 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 here in front of the c. The variable name can be anything. It's the actual dot 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 that makes it the rest parameter. And we're going to come into here and we'll just say console.dir c, and then we'll do it 1, 2, 3, 4, 5. Save that. Come over to here, and we should see those last three numbers showing up in an array right there. So rest parameters are really nice. Use this instead of arguments, especially with arrow functions. Arguments are not going to work with arrow functions. They will work with functions defined with the keyword function, but we're going to be doing pretty much everything with arrow functions. So make sure you use rest parameters if you need to grab additional parameters which may not be represented by named parameters for your function definition. Okay, one last thing we want to take a quick look at here is the actual spread operator. So what we're going to do is we're going to come into here and create a list of numbers, and we'll say nums. There we go. And we'll create our little doit function here again. Okay, so what we're going to do now is we want to pass in this array not as like an actual argument. We don't want to do this. We don't want to say do it and then pass in nums and then just simply pass in a parameter as a here. So if we were to take this piece of code here and run this and then come over to here you'll see we get 1, 2, 3, 4, and 5, but then all the rest of the parameters are undefined. Instead, what we want to do is actually spread this. We want to put a dot, dot, dot in front of it, and then when we put the dot, dot, dot in front of it like this is going to spread the array over the parameters into the function. So we'll save that right there. Come over to here, and now you can see we have A, B, C, D, and E all lined up with the numbers from the array. This is what's known as the spread operator. So you can see the spread operator with the rest operator and destructuring is very powerful in terms of being able to work with variables and pick properties off of objects, populate arrays, pull values out of arrays, pass values into functions, work with extra arguments to functions, that kind of thing. Next on our list is the ability to work with fetch and promises. Fetch is a new API for performing AJAX calls, and we're going to be using fetch in our code to pull down data from our REST service. We have a very simple REST service set up. It's based upon this db.json file. There's basically just a bunch of widgets in there, 4 of them in fact, and we're going to be able to query the REST service to get access to these widgets. Now, in order for this to work, we're also going to have to understand how promises work. We're not going to cover promises exhaustively, but I'll show a couple of examples here of how they work, and we'll be utilizing them in the code that we write. So I'm going to say fetch, and fetch, the fetch API is built directly onto the window object. So if you want to say window.fetch, you can do that. If you just want to say fetch by itself. Now, because we're using TypeScript, TypeScript doesn't necessarily know what fetch is because it's not part of the standard window object API yet. So we can say declare var fetch here at the top, and it will actually declare fetch for us, and then we can make use of it here. This is just basically telling TypeScript, hey, don't get upset that we're using this thing called fetch. So now we're going to say fetch slash HTTP, actually let's do HTTP slash localhost, and our REST server is running on port 3010 slash widgets. And this will actually reach out to the REST service and pull down the widgets. Now, the fetch is totally promise-based. So we're going to say then res.json. This is actually going to take the content and process it as though it's JSON, which it is because that's how we have our REST service set up. Then we can get back the results. And for here, we're going to say console.log results. We can see what those look like. Now, the idea with promises is this whole concept of then. Basically run this first operation, then run this operation, then run this operation. Okay, each of these operations is going to be asynchronous in nature, except for this final one, which is just simply outputting to the console. Okay, and promises are really nice. You can use promises to chain asynchronous operations, to group them together with promise.all. You can include error handling. For example, if there was an error that occurred, we could say catch, and then have some type of handler here for the error. All right, we have asynchronous, basically an asynchronous try catch block mechanism here for handling that error. So promises are really nice in terms of what they do for you for managing those asynchronous operations. Way better than actually, doing the whole callback function mechanism. So let's go ahead and run this code. Let's take a look at the output. If we come into here, you're going to see we have our 4 objects, and here's our actual widget data being pulled down. And really, this is a lot easier to work with than working with jQuery or something like that, and it's even easier than working with the XHR object. It's a really nice API. And since we're running everything in Chrome, it's available in Chrome. It's definitely not going to be available in older browsers, but it should be available in newer browsers. And there are polyfills for fetch too, in case you're working in a browser environment that doesn't support fetch. You can always install the polyfill and then go ahead and make use of it anyways. Okay, so the last thing we're going to talk about here is working with modules. We're going to be building not a huge application, but one large enough to justify breaking it into multiple files. So in order to work with modules, got a couple of concepts here I want to introduce to you. So the first one is that when we create modules, we can be using modules that are provided to us by Redux and React, those kind of modules, or we can create our own modules with our own code in it. So let's start first with our own modules and import those, and then we'll take a quick look at how to work with Redux and React. So I'm going to create under this JS folder, I'm going to create a new file, and I'm just going to call this mod.tsx. So there's mod.tsx. And what I want to do is I'm just going to export something from it. So I'm going to say export const, and I'm going to export a value here. We'll call it new value, and we'll give it a value of 2. And we're just going to export this value right here. And then we're going to come over to here and we're going to import it. So we're going to say import new value. And we're going to say from, but then we're going to specify a relative path. And this relative path is going to be to .mod. And we'll go ahead and save that. And now we'll come over to our web browser here. And you'll see we output the value of 2. So this /mod means we're going to be pulling in mod from our local file system right here. And then the import new value is going to be the variable name that's exported here. And this could be anything. Like you could have this point to a function, to a class, whatever. You can import it. Now you're not limited to only exporting one thing. For example, we could come in here and we could export as something else. We could say export const new value 2 and give that a value of 4. We'll save that. Come into here and then just say new value 4. Actually, new value 2. There we go. And then we can output both values, console.log, new value 2. And then we can save that. And we'll come back to our browser over here, and you can see there's 2 and 4. Now, what about importing everything? What if we actually wanted to pull in new value and new value 2, but not have to manually specify it here? We can also do something like this. We can come into here and we can say star and as mod, and then come down into here and say mod.newValue and mod.newValue2 and save that. And then come back over to here, and in fact let's change these values just so we can see updated values. And now you see we have 3 and 5. Okay? And what that allows us to do is basically pull in everything without having to be explicit. Now, as a general rule, you really don't want to take this approach. You really want to pull in things individually. And that's because in the long run, ES 2015 modules are going to support something called tree shaking, which will basically allow some type of static file analysis mechanism to basically drop out code that's not necessarily needed based upon what's actually imported. However, when we're working with older libraries like a React, we'll use this technique to pull in React so that we can then work with a React global variable. So let's go ahead and take a quick look at that here real quick. When we go to import React, we're going to basically say star as React from React. This will allow things like react.createElement to work. This is important because when JSX does its transpilation, it produces function calls with React dot in front of it, which means we need this kind of global variable here in order for createElement to be called correctly. If we simply just said createElement, then when the JSX transpiles the code, it simply won't find createElement because it's not hanging off of React. On the Redux side, though, we don't have to do this approach. On the Redux side, we can simply say Redux, and then we could do create store. And then when we go to run our code, we'll actually call create store and make use of it like that. Now, in the case of Redux and React, these are not being pulled from our local folder. These are actually being pulled from node modules. And you'll know that because there is no file path being used here with Redux. There's no like // or anything like that. It's just simply the name of the package. And so this will actually go to node modules and locate it there for us. All right, our next topic here is going to be reducer functions. Now, reducer functions are actually pretty simple, but it sounds kind of weird. Like the name sounds weird. Like, what does it mean to reduce something? Take a list of numbers like 1, 2, 3, 4, and 5. That's like an array of numbers. If we wanted to reduce that list of numbers, we could do, for example, summing them. We could just sum up 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, and 10 plus 5 is 15. We could actually create a reducer function that would do that. So it's kind of like we have like a larger piece of data, and then we reduce it to something else based upon some type of function that is applied to that data. Unlike a list of numbers and doing the summing, we're not going to be, quite doing that with our state object, but it's the same idea. As each action comes in, it's going to be reduced, and a new state will be produced. These reducer functions that as we mentioned before, are pure functions. This is really important. In a lot of classes that I teach, students always want to make asynchronous calls and do other things like that out of these pure functions. And what they're not understanding is that the pure functions themselves simply receive the completed action and the current state and then produce a new state from it. All of the asynchronous operations or database calls or whatever it is you're trying to do, all of that is the action creation process, the actual process of making the actions that are passed into the reducer function. The reducer itself is a pure function. There are no side effects. It simply works with the inputs and always generates a new output. Also, reducer functions should be configured to create an initial state during the first run. We'll take a look at how to do that. So let's do a demonstration on reducer functions. In this demonstration, let's take a look at what reducer functions are. And what we're going to do is we're going to start off with the built-in array reduce function provided by JavaScript. And we're going to use that as a building block for understanding what these reducers actually do. By the time it's all said and done, we will have built kind of a general purpose standard reducer function for Redux. And then we'll incorporate that into our next demonstration when we actually create a Redux store. So with an array, let's say we had an array of numbers here. So we'll say const nums, and let's make that a little bigger there. There we go. So const nums and 1, 2, 3, 4, and 5. And let's say we basically wanted just to sum these numbers up. So we could use a reduce function to do this. We can reduce the array of numbers down to a single value. So we'll say nums.reduce, and then we're going to pass a function in here. Now this function that we're going to pass in is going to take two parameters, a previous value and the current value. So we'll use an arrow function here. We're going to have the previous, and then we'll have the current, and then we'll come into here, and what we're going to do is we're going to return back a new value. So we'll say return previous plus current. Now, on the initial iteration, the previous value will actually be the first value in the list, which will be 1. The current value will be 2. So we're basically going to take 1 plus 2 and return back 3. Then when it iterates to the next number, 3, the previous will now be 3, and we're going to add it to the current, which will be 3. And then so on and so forth. And this will repeat all the way through to the end of the list. In fact, what we can do to kind of see what this looks like is we'll say console.log, and we'll do previous, comma, prev, and then we'll say current, comma, current. And we can actually see how this thing gets built. And then at the end, we're going to have a total sum. So we'll just say const sum. And then we'll come down here and do console.log sum. There we go. So we'll go ahead and save that. And now what we're going to do is come over to our web browser. And we can see we have our live reload working. And we can actually see the results here in the console. And you see the value for previous here was 1, and then the current was 2. And then we added those two together, and we had 3. And then the current was 3. We added those two together. We had 6. The current was now 4. Added those two together. We now have 10. The current is 5. Add those two. We end up with 15. So we basically reduced the array of numbers down to a single sum. So looking at this, you get an idea for how this reduce function works, how reduction works. You take this list of numbers and you basically reduce it down to a single sum. It's kind of like the idea of having like a previous value and then modifying it with a new value to produce a new value. And then that cycle continues on down the line. So coming back over here to our code, what we're going to do is we're going to change up the terms here a little bit. Instead of calling this previous, we're going to call this state. And instead of calling this current, we're going to call this action. So we're going to think of it in terms of an action modifies our state. For example, I am hungry, so I decide to go eat. When I eat, it modifies my state of hunger to feeling full, and then I don't want to eat anymore. Okay? That kind of idea. The end result of this process is going to be what we'll call our final state here. Now, there's nothing magical about the term final state. I'm just using the term final state to indicate that, hey, we're done processing all of the actions that are going to occur. And we'll copy this and paste this down here. There we go. Now, we're going to look at these nums. Instead of looking at them as nums, we're going to look at them as actions. So we'll just view like an action of 1, an action of 2, an action of 3, so on and so forth. So we're going to come down here, we'll modify our labels here slightly, and we'll say state, state, and then we'll have action, and we'll have action. There we go. And for right now, we're simply just going to resum these things again using our new terms. There we go. We'll save those values, and let's actually change our nums here to actions as well. There we go. So now we're going to iterate over our actions, and we're going to be updating the state from starting with an initial state of 1, and then eventually applying these actions, and then ending up with our final state here at the end. So if we come over to the web browser, and we take a look here, we'll see we have a state of 1, action 2, state 3, action 3, so on and so forth. You can kind of see how the state's being changed over the course of time. So what we're going to do is jump back over to here, and we're going to build out these actions a little bit. So instead of just having like 1, 2, 3, 4, and 5 and just supporting only one kind of action, we can actually have many kinds of actions. And so what we'll do is we're going to change these up a little bit to kind of make them do a little bit more than just do some summing. To do this, we're going to have a way of indicating what the action is, like what does it do. So we'll come into here, and we're going to set up an object. This object's going to have a type property. And the first action that we're going to do is we'll add one called add. And then we'll have value, and then the value that we're going to add. Excellent. So let's go ahead and do the same thing here for 2. For this one, though, we're going to do subtract. So there's our subtract, and then we'll have ourselves a new value. So to do that, what we're going to do is we're going to add a switch statement. And we're going to come into here and say action.type. And then we'll set up our switch statement. We're going to add a case, so we'll have a case for add. And all this is going to do is basically take our current state. There we go. And then we'll have a case for subtract. Return state minus action. Great. And then finally, when we have a default situation, we're simply going to say default and then return back the original state. There we go. So now what we're going to do is we're going to receive each of these states. We're going to process the action, producing a new state based upon whatever the desired action was for its type. And then we'll produce a final state value here, and we can kind of see how the whole thing builds all the way through here. We do have one little problem though. For our action, we need to make sure we put .value. We just simply can't do the operation based upon the object itself. That doesn't make any sense. And what's really nice is TypeScript actually caught that for us. The little red lines here, it caught that for us, saying, hey, look, you can't do this this action operation against state because it looks like state's going to be a number, and because it's going to be a number, you just can't simply add and subtract objects from it. So we'll say action.value. .value. So what we can do is we can actually specify an initial default state by passing in a second parameter here to the reduce function. So this will be the initial value, and we're going to set our initial state here at 0. And we'll go ahead and save that. and then we're going to switch over to our web browser, and let's take a look at what we have here. So we start off with this state of 0, and we're going to have an action add, and we're going to add 1. So our state now has a value of 1. The next time we're going to subtract 2 from that, so now our new state is -1. Then we're going to add 3, and we have a state of 2. And then we're going to subtract 4 and have a state of -2. And then we're going to add 5 and now end up with a final state of 3. As you can see here, the state changed as each action was applied to the reducer function, and a new state was returned. So that's really the whole concept behind reduction, or in terms of reducers for Redux. The idea of having this state and then having this action passed in, and then that state being changed in some way. There's one last really important thing to understand about working with state in Redux. The state is immutable. Now, when working with a value such as this, we're not actually mutating the state variable. We're simply just taking its value and adding it. But if we were working with an object, this gets a little bit more tricky. The problem is that when you're working with an object, if you start changing properties on that object, you're basically mutating it. And you don't want to be mutating the state object. Instead, you want to produce a new state object. So to kind of demonstrate this here quickly, what we're going to do is we're going to come down here where we initialize this new state object right here, and we are going to put a sum property on here. So our sum right here is just going to be a property, and it's going to be just a regular state object. And then we're going to interact with this state object inside the reducer function. Now, it might be tempting to do something like this, to actually come into here and just say state dot sum, plus equals action dot value, and then return the state. The problem is if you do this, this will be mutating the state, and we do not want to mutate the state. We have to produce a new state object every single time. So the question then becomes, how do we work with this to produce that new state object? Well, what we can do is actually come in here and say object.assign, and we can specify a new object. So this is going to create a new object out of thin air. We can then take our state object, and this will copy over all of the properties. So even if our reducer function isn't working with all of the properties on the state, by copying over all the properties, we can ensure that we're not going to leave anything behind. Then we can finally put the stuff that we want to modify here. And so we'll come into here and we're going to say sum, and then we're simply going to say state.sum, and we'll say plus action.value. So the result of this is to basically copy over this sum property with the updated sum value to this object that's being created here. And so this will capture all of the state properties, and then we can overwrite the specific one that we're looking for on our new state object. And now our new state object is a totally new object, okay? And we don't have to worry about mutating it, which is what we don't want to do. And so we'll just copy this piece of code right here, and we'll paste it right down here, change that to a minus, and now we have a situation where we are basically producing new state objects instead of mutating an actual object. Now, come down here and we're going to actually just output our final state object here. We could do the sum if we want, or we could let it output the whole object. Either way is fine. So we'll save that. We're going to switch back over to our web browser and take a look here. And now you can see we're producing new objects every single time for our state. And each object here is different. They are not the same object, which allows us to basically go back and refer to the previous state if we want to. We have all of that still put together in an object, so that if we wanted to have like a history of states or implement undo functionality, we'd have the ability to do so. And so that's the basics of reducer functions. These are the functions that are going to drive your application. Okay? All right, working with stores. Stores are the container for applying the action to the state using the reducer function, and they also contain the current state. We can create stores using the create store function provided by the Redux library. The first parameter to create store is the reducer function itself, And the second parameter is an optional initial state. If this is not provided, then the default state initialized by the reducer function will be used on the first run through. For store initialization, when you initially create a store, the reducer function that's passed in is actually executed with no action, allowing the default state parameter value in the reducer functions to initialize the application state. If an initial state is actually passed into the create store, then that initial state is what is passed to the reducer function when the store is created. Handling actions with the store. When an action is created in the system and it needs to be handled by our store, we're going to pass that action to the store through the use of the dispatch function. So we're going to call the dispatch function, pass in the action object. Now, all action objects must have a type property. That type property will be used by the reducer function to determine how the state is going to be modified as a result of that action. On the action object, there's also other relevant data too. So it's not just the type, it's the type plus any other data, such as data that comes back from REST services. And that's how that data is then passed into the actual store. Once an action has been dispatched and once the reducer function has produced the new state, the question is, how does that new state get transmitted to all the things that are interested in it? Well, it turns out that there's a subscribe function, and the store will allow things that are interested to actually subscribe for state changes. And so take, for example, a React component. A React component could then register with the store and say, hey, when you get a new list of widgets, let me know so I can update my list of widgets. So anything can subscribe to the store that wants to. Typically, it's going to be UI components. Now, once the UI component's been notified that the state's been updated, the state itself is actually not passed through the subscribe function. Instead, the thing interested in the new state can actually reference the store and then call the getState function to retrieve back the state that has been updated. So let's take a quick look at how to work with stores. In this demonstration, we are going to take this reducer and incorporate it into a React store. And we're not only going to do that, but we're going to do it with TypeScript. So we're going to take a look at how you set up a reducer using TypeScript, how you define your actions, how you configure your application state, and then finally, how do you tie all that together in an actual Redux store and be able to dispatch those actions as well as to subscribe to the updated states. So let's go ahead and take a look at how to do that now. The first thing we're going to do is we're going to come to the top here of our file, and we are going to set up an enumeration that lists all of the actions in our system. Now currently we only have 2 actions, so we'll go ahead and just set up 2 actions here in our enumeration. So we're going to say enum action types, and then we're going to have add, and then we're going to have subtract. Okay, so these will be our 2 actions. Next, we need to create an actual action interface. So basically kind of create an object shape that will reflect the properties that our actions will actually have. We can kind of see that already down here in our array. Our actions have a type property, but they also have a value property, the value that we're either going to add or subtract from the sum of the state object, or the sum property of the state object. So to do this, what we're going to do is create an actual interface. So we're going to say interface, and then we will create our action here. So we'll just call this calc action, and this thing is going to actually extend the action interface provided to us by Redux. So we'll come into here and say action, and then in order to resolve what this is, we're actually going to import Redux into our page. So we'll say import action from Redux. As I mentioned before, Redux has TypeScript definitions built into it. So we just simply can pull these definitions in, and then we can make use of them to build our stuff. So on our interface, the type is already provided by the action part of this. So we're simply going to add the value to this, and this is going to be of type number. And so there's our calc action interface. Now the next thing we're going to do is we're going to create some action creator functions. Basically, these are going to be used to produce the action objects based upon some set of input. So we'll create one action creator function called create add action, and then we'll have a second function, const create subtract action. Now we're going to have to decorate these things up a little bit with some TypeScript stuff, as well as actually build out the actual action creation itself. So coming into here, the first thing we're going to do is set the type of this thing to be a function which returns a calc action. And we will also do the same thing down here for this one, a function which returns a calc action. Now we're also going to have some input parameters here. All right, so the actual value that we're going to be either adding or subtracting. So we'll just call this value, and we'll say number, and then we'll have value, and we'll say number there. And then we can simply just come over to here and specify value as our input parameter. So far, so good. Now this here, we don't actually really need to do a whole lot of work to produce the action object itself. We can actually just set up these arrow functions to simply return back a new object. And we can do that by wrapping the curly braces here in parens. And we'll do that right here. Excellent. And now we have to specify a type. So we'll say type, and it's going to be action types. And we'll do add. And then finally, we can just say value. Because our variable here in A is named value, and our property on our calc action is called value, we can just simply put value here, and that will serve not only as the property name, but also the source of the value for populating the value property. And then we can say type action types subtract, and then we can simply say value again. So now we have two functions here that have been created for actually creating our actions. So now that we can create our actions, we need to write the reducer function that can actually process the action. So to create this reducer function, what we're going to do is we're going to come up to here, and we are going to import reducer from Redux. So we're going to be able to have this strongly typed, and we'll come into here, and I'm going to create const reducer, and then I'm going to be able to say reducer. Now the interesting thing about reducer is that reducer is a generic type. It's looking for the actual type of our application state. So what we're going to do is we're going to come up here, and we're actually going to create an interface here for our application state. So we will say app state, and we're actually going to make that an interface. And then for this, we're simply just going to come into here, we'll do that. And then all we're going to have on here is basically the sum. So we'll just say sum, and this is going to be a number. So that'll be our actual application state object, or type really. And then we'll say app state. And then we'll go ahead and set up our actual function here. Now, we're going to be having our state, as we learned before, and our action will be passed in. There we go. And then following that will be the actual function implementation. So now down here we have these actions that we created earlier. We can go ahead and actually just delete these. We're not going to need these anymore. We'll recreate them using the action creators. For our state logic here, we don't need this actions.reduce or any of that, but we do want to go ahead and hold on to some of this logic right here. We don't need to re-implement all of that. So we'll copy that, paste that into here, and then we'll have to make a few adjustments. We'll go ahead and pull all this down here. Now we are going to want to initialize our state initially. So let's say our state doesn't have an initial value set or something like that. We're just going to come in here and say sum : 0, and we can initialize our state with a parameter initializer right here. Next thing we need to do is actually come in here and specify the types for this right here. So we'll say app state, and then for our action, it's going to be of type calc action. Okay, looking good. So we'll actually just kind of collapse this window or collapse the sidebar over there so we can see this a little better. So now we have our reducer, everything is strongly typed. We now need to come in here and actually make a few little changes here for making this work right. So you saw earlier we had this type, and it was action type, subtract, and that kind of thing. And what we want to do is we're going to take this enumeration, and we're going to reference that down here. So we'll say subtract, and then for here we'll just come in here and say add. So that'll find that. And then here we have our object.assign with our state, and then setting up our properties on here just like this. And then down here, we no longer have a final state, so we can actually get rid of that. So now we have a reducer. So before we actually create the store, let's kind of review what we've just created. At the top, we created an enumeration for our action types. We then imported action and created our own custom action with a custom property. We then created two action creator methods that took an input value and then set up an action based upon a certain action type. Both of these will return a calc action object. We then set up our state to have an interface, and it's going to have a sum property. We then produced a reducer function, which actually has a strongly typed state and a strongly typed action. And then we actually have our regular standard reducer functionality, although it does make use of our enum. And of course, at the top here, we are importing the Redux library and pulling in the necessary TypeScript definitions that we need to be able to make all of this strongly typed. So the next step is to now go ahead and actually create our store. And to create our store is pretty simple. We're going to come up here and we're going to pull in create store. And then down here, we'll go ahead and actually create that store. So we'll say const app store. You could just call it store if you wanted to. And this is going to have a type of store app state. So we'll need to make sure we pull in the store up here as well. There we go. And then we'll say equal create store. And then we'll say app state. And then we're going to pass into this our actual reducer. So here's our reducer here. There we go. And there's our store. Now, of course, if we were not using the TypeScript approach, there'd be a whole lot less JavaScript here. You wouldn't have all of this stuff here for setting the types and everything else. But I'll be honest with you, TypeScript is awesome. And I really started to fall in love with TypeScript when I was doing Angular 2 programming. And really made life a lot easier, and I felt like I could write better code, and I knew that everything was going to work together the way it was intended to work. And especially on large enterprise class projects, you know, all of this strong typing is just really, really, really helpful. And so as you can see, Redux really makes this really easy out of the box, providing the TypeScript definitions just as part of the actual, you know, NPM package for Redux. It's really awesome. So let's go ahead now and let's wire up this store to do something useful. So we're going to say app store dot dispatch. And into this dispatch, we can actually pass in an actual action. Okay? So we're going to say create add action. And then we're going to add, let's say, 2. And we'll just do a couple of these. Copy, paste, paste, paste. And we'll do 2, and we'll do 4, and 3, and we'll do 7, and we'll do 1. And we'll make a couple of these. Add, we'll do some subtracts in there. Okay, great. So now we have a bunch of actions pushing through these different values. Now what we can do is actually register a function to respond to these actions, or to these actions being dispatched. So we'll say app store dot subscribe. There we go. And then we can basically subscribe to this and register a function. And we can just do a little console.log. Action was dispatched. State was reduced. And then we'll actually output the new state object. So we'll say console.log. And to do this, we simply are just going to say app store.getState. So you'll notice the state itself is not actually passed into the function that's subscribed. Instead, you actually get that state off of the App Store here. So we can save all of this, and we'll head back over to our web browser. And everything should have been reloaded. If we take a look here, action was dispatched, state was reduced. So now we have a sum of 2. And then if we head back over to our code here, we'll see where we had 4. So now we subtracted 4, we're at -2. We then had 3, and we added that, so now we're back up to 1. Then we subtracted 7 at -6, and then we added 1 back, and we're at -5. But you can see we produced a new object every time. But it's pretty nice. You can now basically hook into the store and be notified whenever actions come through. And now actions have a nice way of being dispatched into the Redux store, and then of course being properly handled. Now, conceptually, at the end of the day, when it's all said and done, your components are going to subscribe to the store to receive updates. And basically, interactions with your application will trigger actions. For example, a button click. A button click would result in an action that would then get dispatched. Then in response to that action being handled and the state being updated, the component, through the subscription, would be notified of the new state and then be able to handle it. Now, actions can not only come from, let's say, a button click, but they can also come through like a WebSocket connection. So if you receive data over a WebSocket and that triggers the message event, that could then produce a new action, which then goes through Redux, and then your components get updated. But the idea is that basically everything has to flow through this store to get to the components to be updated. Nothing impacts the UI unless it goes through Redux. And through such a system, it's very easy to reason about your data and make sure that everything is staying synchronized in your system and in your UI especially. Now that we've learned how to work with reducers and stores, when we start working with larger applications, our reducer functions can become quite large. And in fact, it's very common to actually take a large reducer function and break it into smaller reducer functions, with each function being responsible for a part of the state tree. Redux actually makes this really, really easy to do. And by breaking these things apart, it results in easier to maintain code and easier to understand code. By breaking the larger reducer into parts, it makes it easier for us to write maintainable, more understandable code. To help us with this, Redux provides us a combine reducers function where we basically can pass in our various reducer functions to produce a single reducer function, which is then passed into the create store function. Let's take a look at a quick demonstration of how we can combine reducers. Very commonly, when you work with Redux applications, the state tree can grow quite large. We don't really have time in this video to build a huge state tree, but we can kind of demonstrate what it would look like if you had multiple top-level properties on your state tree. And in cases like that, it's very common to want to divide the reducer functionality to have a reducer function to work on part of the state tree instead of the entire thing like we currently have. So what we're going to do is we're going to come up here to the top to our app state interface, and we're going to collect a second piece of information. Instead of simply just having the sum with our number, we're actually going to build a little history. So we're going to have a history here, and then the history is just going to be an array of strings. And the way this is basically going to work is that as we make each operation, we'll just store in this history array, we'll store what that operation was, and then we can go back later and actually print it out. So we'll come down here, we're going to set up our initialization to have our history initialized here to an empty array. There we go. So now we have our TypeScript there. You can kind of see how nice TypeScript is. It really just tells you where you got to go fix what's wrong. Now, inside of our reducer here, we currently have code that would allow us to record this history. For example, we could come into here and do something like this. We could take our state. Actually, let's come grab over here, create a history object. We'll say const history. And then all we're going to do here is say state.history.concat. And then to this history, we'll just add a string here. We'll do a little template literal or string literal here. And we'll do operation. And then we'll say add. And then we'll put a little comma. And we'll say value. And then we'll do a variable here. And we'll just type in action.value. There we go. And then we'll just come over here and take this history, and we'll pop this history right here onto this object. And the concat operation will basically produce a new array. So we're not mutating the original history array on the original state object. Instead, we're producing a new history array and then setting it up on this one here. And we're going to take this piece of code right here, and we'll put it down here and just change the operation to be subtract. And now we are going to basically have a history here that will then be used to update our state object here. And of course, we do have one problem. We're kind of redefining history twice. We don't want to do that. So we'll just copy this right here, move this to the top, paste that. We'll make it a if strings, and then just get rid of the const here. And let's actually change that to a let. Okay, great. So now I've got my history here. I'm going to concat my action onto it, and we're going to have a history of our operations. And we'll actually be able to see that our history here has, goes from having, 1 to 2 to 3, and so on and so forth. And if we expand this out, we can actually see the history array, and we can see our history of operations. Now, right now, the code that we're writing here in our reducer is operating on two parts of the state tree. It's operating on the sum part of the tree as well as the history part of the tree. So using combined reducers, what we can do is we can actually set this thing up so that we could have two separate reducer functions, one operating on sum, one operating on history, and then combine them together to create our store. So let's go ahead and set that up now. So we've got this one reducer function here, and we're going to call this our sum reducer, and we'll simply copy the whole thing and we'll paste it here, and this will be our history reducer. And now up here, what's going to be different about this is that the state being passed in here is no longer going to be the entire app state. Instead, the state being passed in is literally going to be the sum part of the tree. Well, sum is nothing more than a number. So we can come into our reducer here and basically change this from app state to number, and then come into here and change this part here to simply be number, and then change this thing to simply be 0, and then we still have our action. I no longer need history. Get rid of that, get rid of that, and get rid of that. I also no longer need to do all this object assigning. One nice thing about working with reducers that work on part of the tree is you can eliminate a lot of this object copying around. So what I'm going to do is come over to here, and I'm going to basically get rid of this, and I'm simply going to return back the state plus this value here. There we go. And then I can have my state here minus a value. There we go. And then of course return back the default one here. So there's my sum reducer. We'll come down to history. Now history is going to have some of the same changes. We'll change that to a string array. We'll come into here and simply change this into a string array. And that looks good there. I'll get rid of the curly brace. Excellent. Okay, and then we'll come into here. We can keep our let history, and actually we can even get rid of that, because we can just come into here and say return state.history.concat, and we can get rid of the history part because we're already operating off of the array. Get rid of that. Simply change this to be return state.concat. There we go. So now we have our history being updated. And now we need to actually combine these together. And the way we're going to do this is that we're going to pull in a couple of things up here at the top from Redux. First thing we're going to pull in is the combine reducers. Then we're going to pull in the map, or reducers map object. That's what we're looking for, the reducers map object. And we'll take this reducers map object, and we're going to come down here, and we will create a new variable called reducers map. Paste that in there like that, and we're going to set this up as a new object. We'll have sum, and sum is going to point to sum reducer, and then we'll have history, and history is going to point to history reducer. So now we have this map setup linking this part of the state tree sum to this reducer and this part of the state tree history to this reducer. I can then take my reducers map right here, copy that, and come over to here and actually say combine reducers, app state, and then pass in my reducers map like that. And now by doing that, I now have the ability to run my operation on each part of the state tree without having to have one big reducer function and having a greatly simplified history and sum reducer function. You can imagine for a large application, the ability to combine reducers like this would be absolutely essential. So we'll go ahead and save that, come back over to our web browser, and let's see here. Reducer history returned undefined during initialization. So let's go take a look to see what our issue is here with our code. So here, when we had our state number equal to 0, we did not initialize our array on our history. So let's go ahead and fix that real quick. Save that. Head back over to our web browser. There we go. Everything's working again. So now if we come into here, we can see we have our history of operations and we have our calculated sum value. So as you can see, working with combining reducers is extremely powerful and can really result in easier to understand code. And when you think about actually writing unit tests and stuff like that for your code, writing a unit test against a sum reducer and a history reducer that are separate would be much easier than writing a bunch of unit tests against a single reducer that had all of this functionality combined together. So now in our final section, we're going to take a look at how to integrate React with Redux, as well as how to do asynchronous programming. React does not have to be used with Redux, and Redux does not have to be used with React, but it is a popular combination, so it's worth taking a look at how the two of them can work together. Also, we're going to take a look at some asynchronous programming and talk about how to manage state within the context of making AJAX calls using the fetch function. Now, we're not going to be looking at the React Redux library. That would be a whole other course in and of itself. Instead, we're just going to take a look at how to hook in Redux into React using some of the lifecycle functions provided by React components, as well as how to integrate the state that's managed in the Redux store in a React component. On the asynchronous programming side, this kind of confuses some people. They get a little confused about how does this actually work with Redux? And what you find is that asynchronous programming kind of operates outside of Redux. Basically, asynchronous coding just generates actions, and then those actions are handled by Redux. It doesn't really matter where those actions come from, so long as all the actions that occur travel through Redux to do the state modification using the reducers and then ultimately passed on to the components. So we'll kind of take a look at the concept of a pending request state and a fulfilled request state and take a look at how that works. So let's take a look at some demonstrations here on how to integrate React with Redux, as well as how to use asynchronous operations. In this final demonstration, we're going to do a quick overview of looking at using Redux with React, as well as incorporating asynchronous operations to kind of give you an idea of what this looks like. We're not going to be using any of the middleware that's advertised on the Redux website for doing asynchronous operations. We're going to kind of just do this manually ourselves, and we're going to take a look at what it actually looks like when you use Redux in combination with the UI library. Now, you don't have to use React with Redux. It's a very popular combination. There's an actual library that's been set up that provides some functionality for making that integration easier to do, but it's certainly not required. You can use any UI library you'd like to with Redux. But let's do a quick little look here at this application. Now, if we go over to the web browser, you're going to see that we now have our table of widgets back. And so what I did was I came into here and I moved our file that we were working on earlier to the demo folder, and then I copied back over the original files that were here when we started this course. And we're going to take a look at these files to understand how this whole thing works. Now, these files are nicely set up. I've kind of divided everything up into different files, and we're using the module system to include modules and that kind of thing. And so it's definitely nicely broken up. But the downside to that, though, is we're going to have to go look in a bunch of files to kind of see the pieces and parts to see how they kind of work together. So our starting point here is going to be actually the reducer itself. So here's our reducer. And we're going to start from the reducer and work back to the actions. And then we'll come back to the reducer and work our way forward to the components. So the basic idea of our reducer here, which is really the heart and soul of the Redux part of the application, is that we have two types of actions that we're paying attention to. We have an action called request and an action called done. Now, the actual names used here, there's nothing magical or special about them. It's just what I chose to call them, but they represent two different states when working with asynchronous operations. When working with asynchronous operations, we have one state, which is the actual process of requesting data from the server, and we have a second state, which is the actual result of getting the data that comes back from that request. So if you kind of think of it like this, like the first request is kind of like a pending type of thing, like we're waiting for the results. Picture like a spinner on the screen. And then once the data actually comes back, we switch to the state where we have the data. The spinner goes away, and then the UI is updated with that information. So if you take a look here, we have a little reducer function that's going to work with these two states. And really what we're doing is just requesting a list of widgets. And you can see that in the request state, we're going to take our list of widgets and kind of initialize it back to an empty array. But then once we accomplish the AJAX operation and download the widgets, we're then going to take the widgets that we've received and we are going to basically update the state with those widgets so they can be displayed by the user interface. So now that we understand what our reducer is doing, let's take a look at how these actions actually get created. This is going to be the asynchronous part of the actual application, understanding what's really going on here behind the scenes. So to do this, we're going to come back over here, and we are going to go to our actions folder. And inside of here, we're going to see a file called refresh widgets. There we go. And this is going to have our action configuration in it. So if you notice here, we're going to have two action creator functions. One where we're going to have the refresh widgets request, and then one where we're going to have the refresh widgets done. So here this is going to be initialized to an empty array, and this is going to be the actual array of widgets that's being passed in. So let's take a look here at the refresh widgets function, which is actually going to be responsible for interacting with the store to dispatch both of these actions. All right, so you'll notice here, first of all, we're not doing these asynchronous operations inside the store itself. Okay, the store has no concept of doing asynchronous ops. Why? Because asynchronous operations are not pure functions. Asynchronous operations interact with other systems. They have side effects. They have data coming in from other places. That's not how reducers work. The way a reducer works is you have inputs coming into the reducer, and it produces a new state object as the output. No side effects, all right? All the data is coming from the same place. The state itself is immutable, whereas when you're working with, REST services, GraphQL services, databases, whatever, none of that stuff is immutable, all right? And there's all types of side effects. So here we're going to use this refresh widgets function to actually create the actions and dispatch them. Now the first one we're going to dispatch is, think of this as like dispatching the action to make the spinner show up on the screen. This is the action that says, hey look, we're going to go out and request for a bunch of widgets. So we don't have any widgets for the moment. We're just going to have to wait until we get them. That's our first action here. Next we have our second action. Now you're going to notice our section action is part of a promise chain from a fetch operation, actually making a call out to the REST service to download the widgets. So you can see here we are saying create refresh widgets done action, and then we're going to dispatch that. And we're going to call that once we actually have our widgets from making our REST service request. And so that's what's going on here. So we're going to dispatch the action saying we're making the request, and then we're going to dispatch the action saying we received the request. Now each of these actions will be properly handled by the Redux store, being processed through our reducer function, and then ultimately notifying our UI library, hey, we either, we're requesting widgets or we have the widgets and so you can display them. Now, coming back over to our reducer here again, inside of our reducer folder, We have our reducer, and we know that this reducer actually gets passed into a create store function to produce the Redux store. So we're going to come down here, and we have a store file. And you can see here we have our create store function with our app state, very similar to what we talked about in the previous exercise. And we're passing in our reducer function, and it's going to produce our app store here. So now that we have our store, and we saw that our action creators were basically invoking the dispatch function on the store to actually dispatch the actions, how do we actually handle the results of those actions? How do we hook into those to actually say, hey, okay, when an action occurs and the state is modified, how do I respond to that in the UI side? So we're going to come back over to here, and we actually have a, let's see here, let's go to our app TSX. And this is the starting point here for our React application. We're going to have this thing called a widget table container. The widget table container is not the actual widget table itself. It's going to basically be a container that's going to deal with application state or deal with the actual data that's powering the app. The widget table container is going to have a reference to the actual store, and then that store and its data will be made available to the actual UI components that it wraps up. So here's our app store, and here's our refresh widgets function that we saw a few minutes ago. And take a look here. We're going to say React DOM render the widget table container, and we're going to be passing in our store. Once we do that, we're going to go ahead and fire off refresh widgets, which will go out and actually request the data, firing off the first action saying we're making the request, and then ultimately firing off the second action saying, hey, we have our data now. So let's go on into our widget table container and take a look at what that looks like. So inside of our components, we have widget table container. And if we come into here, we're going to see that we're using React with TypeScript. So there's also a TypeScript definition file for React as well. And you can see where we're extending React component. We're specifying the type for our properties and for our state. I'm not going to go into a lot of detail on that, assuming you know what that is if you've worked with React before. But what I am interested in showing you is coming down here and talking about this component did mount function. This is one of the lifecycle functions that comes with a React component. And basically, once the component has been mounted and is ready to go, you can hook in some code that will do something. In this case, we are going to be subscribing to our store and also unsubscribing if the component is unmounted. But we're going to be subscribing to the store and passing in this little callback function. What's going to happen is that when the store receives an action and processes it and notifies everything paying attention to it that it has a new state, then we're going to have this function execute, and this .setState is going to set the new state on our actual React component. We're going to get access to our widgets by calling the getState function on the store, okay? And then we're going to be able to actually update our widgets here. Now, when that happens, the updated widgets are then going to be passed down as a property into the widget table. Why do I have widget table surrounded by widget table container? I have it surrounded this way so that my widget table is not dependent upon a Redux store. My widget table doesn't actually care at all where the data comes from. All it cares about is getting a list or a table of widgets. And so that's what we're doing here. We're passing it this table of widgets. Having this concept of a data or state container versus having like a UI container that has everything to do with the UI but nothing really about managing state is a very common pattern in React programming. Now that I have my widget table, let's go take a look at what that looks like. This is going to look like any standard widget table component. It's going to have a table, TRs, THs, so on and so forth. And we're going to iterate over the array of widgets, creating a widget row for each widget in our array. And so this will then be updated with the data that was requested. So you can kind of see how the whole thing kind of comes together. We use React's lifecycle functions to subscribe into the store. We have a set of actions that do the whole fetching thing and dispatch actions based upon the status of requesting data. And then at the center of it, the heart of it, is the reducer function inside the store that takes those actions, creates a new state, and then that new state is available to whatever is listening to it. So as you can see, React is a nice piece of code to use to manage your application state. It can work with lots of different systems. It's not huge and complicated to use. It's very flexible as long as you follow the 3 principles. And it's a great little library for really simplifying the process of managing state within your web application. So in conclusion, you can kind of see that Redux, inspired by Flux, improves the management of state in JavaScript application. It's really built on 3 principles: a single source of truth, immutable state, and pure reducer functions. Redux basically provides a container for applying actions to produce new states based upon the logic of these reducer functions. And we can combine reducer functions together to basically work on different parts of the state tree. Redux is commonly used with React. It can be used with asynchronous operations, but Redux itself is independent of the specific UI library you choose to use.